So this is what I had defined earlier on. So we want to evaluate that sum, and that sum was given. Okay, the sum was not given as such, but the values, those values of probabilities that are being summed, their values within this table. So we have to sum all these values and show that they equate to 1. So we sum 0.1, 0.1 plus 0 plus 0.1, that is 0.2, plus 0, so 0.2, plus 0.3, 0.5, plus 0, 0.5, plus 0.1, 0.6, plus 0.2, 0.8, plus 0, still 0.8, plus 0.2, which is a 1, plus 0, which is a 1, plus 0, which is still a 1. Therefore, this is equal to 0.1 plus 0, 0.1 plus 0 plus 0.1 plus 0 plus 0.3 plus 0 plus 0.1 plus 0.2 plus 0 plus 0.2 plus 0 plus 0, and this equates to 1. Yeah. Another example. Another example on joint discrete. What is this example? Determine the value of k. Determine the value of k for which the function given by f x y equals the kxy, where x is taking values from 1 to 3, and y is taking on values from 0, 1, 2, 3. I mean the value of k for which the function given by that can serve as a joint probability function for 2 random variables, and those random variables are x and y. So we want to find the value of k for which that function is a joint probability function. So you recall from one dimension, if I have a single value random variable, we are summing the possible probabilities and equating to 1. So it is the same thing here. We apply that second property. Which property? The sum over all x all y, f, x, y, x, y, this should equate to 1. And then determine the value of k. So note that x is taking on values 1, 2, 3. So we do the same things as before. One can also decide to come up with a table. I don't know. I think it is better with a table. Anyway, all the same. So you have 1, 2, and 3. Still 1, 2, and 3. So you look at 1, you fix 1, then you vary these others. Fix 2, you vary the others. Yeah. It is something which can also be summarized in a table. That is also possible. So what do we have here? The probability of x equals 1, comma, y equals 1, plus probability of x equals 1, comma, y equals 2, plus probability of x equals 1, comma, y equals 3. So x equals 1 is done. Then plus probability of x equals 2, y equals 1, plus probability of x equals 2, y equals 2, plus probability of x equals 2, x equals 2, y equals 3. So x equals 2 is exhausted. Then I go to x equals 3, probability of x equals 3, y equals 1, plus probability of x equals 3, y equals 2, plus probability of x equals 3, y equals 3. And this should equate to 1. Therefore, I start with x equals 1. As we substitute in our function, what is the function? The function was given as kxy. So I substitute in that function. So I substitute in that function k times x times y. Therefore, if x is 1 and y is 1, substituting in kxy, for that case we shall have k, then plus x equals 2, y equals 2, substituting there we shall get 2k, then plus x equals 1, y equals 3, substituting in the formula we shall get 3k, then plus x equals 2, y equals 1, for that case we shall get 2k, plus x equals 2, y equals 2, that is 4k, x equals 2, y equals 3, that is 6k, x is 3, y is 1, that is 3k, x is 3, y is 2, 6k, x is 3, y is 3, that is 9k, and we equate to a 1. Therefore, we sum, this is k plus 2, that is 3, plus 3, that is 6, plus 2, that is 8, plus 4, that is 12, plus 6, that is 18, plus 3, 21, plus 6, 20, 27, then plus 9. 7 plus 9, I think it is 36. So therefore, we have 36k is equal to 1. And this should imply that the value of k is 1 over 36. Like that. Another example. I believe this should be the last example for joint discrete. This should be the last example, joint discrete.